Hello students, today I am going to explain one of the important problem. December 2023 part C problem it is CSIR Net Mathematical Science. First understand the question. Let n greater than or equal to 1 be a collection of non-empty subsets of Z such that an intersection am equal to phi for m is not equal to n if z equals to union n greater than or equal to 1 an, then which of the following statements are necessarily true? Option A, an is finite for every integer n greater than or equal to 1. Option B, an is finite for some integer n greater than or equal to 1. Option C, an is infinite for some integer n greater than or equal to 1. Option D, an is countable, finite or infinite for every integer n greater than or equal to 1. So students, first try to understand the question. In the question they are saying it is a collection of subsets. After collecting all the subsets, if you take the union, see, if z is nothing but integer, in some book the notation may be I, capital I, in some book z, but z means integer, the set of integer. The condition they have given, an intersection am equal to phi for m is not equal to n if z equal to union. What union? N greater than or equal to an means a1 is one subset, a2 is one subset, a3 is one subset, dash dash so on. The subset of all this union, collection of subset of all this union forms the set of integer. This is the condition given in the question. Now, what the options they have given? An is finite for some integer n greater than or equal to 1. Just we focus on this option A. In option A, what they are saying, an is finite for every integer n greater than or equal to 1. This every word is very important. How to solve this type of problem? What is the logic behind this? Now, you can see here, this is A1, this is A2, this is A3, dash dash so on, and the condition is an intersection am equal to phi for all m is not equal to n, z equal to union n greater than or equal to 1, capital An. Now just listen here, A1, A2, A3, this is the collection of subsets. If this collection of all the subsets, if you take the union and n greater than or equal to 1, then it should form the z integer. This is the condition. Now coming to the first option, what first option says that an is finite for every integer n greater than or equal to 1. Now I will take one example. This is a1, I will take 0, a2 1, a3 minus 1, a4 2, a5 minus 2, a6 3, a7 minus 3, and dash dash so on. I am trying to form this set capital Z, that is integer, by taking the union of the subset a1, a2, a3, a4, a5 dash dash so on. Can I form? Just we will check. A1 is 0, it is finite. Yes, it is finite. A2 is 1, it is finite. Yes, it is finite. A3 is finite, A4 is finite, A5 is finite, dash dash so on. So by this collection of subset, if I take the union of all these subsets, I can form the integer z. See, the number again continues, dash dash so on, because it is an infinite. You know, it is the set of integer is infinite set, but I cannot write complete set because I cannot write infinite set. So I am taking just some sample. So this is this subset, collection of all this subset. By taking the union, I can form the set of integer. Yes, I can form. But the question is that in the question, what they are asking, listen here, an is finite for every integer. For every integer means they are telling this is the only one option. They are telling this is the only one option. If you take all the collection of the subset, if you take the union, then you will get the set of integer capital Z. But I will take another example. You can see here. Example 2. All odd number A1, all even, all negative odd number A2. Listen carefully. A1 I have taken all odd number. This is infinite set. A2 I have taken all negative odd number. This is infinite set. After that I will take 0. This is finite. A4 is 2. A5 is minus 2. And dash dash so on. And A6 is 4. A7 is minus 4. And I can take some number. And I can take, if I take all this collection, if I take the union, I can form Z. Of course I can form Z. Because see, all odd number, this is infinite. A1 I am taking. All negative odd number, this is A2, this is also infinite. But in question saying that, but in questions what they are saying, an is finite for every integer n greater than or equal to 1. Means they are saying this is the only one option. We can form the set of integer by taking the union of all the subsets only finite, because this is finite, this is finite, this is finite, this is finite. But I can form by taking infinite set combination and finite set combination. I can form. I am having this type of choice. So this example shows that the first option is incorrect. Now coming to the option B. An is finite for some integer n greater than or equal to 1. This statement is true. We will see. I will take this multiple of 2, set A1, this is infinite. I will take A2 multiple of 3. I will take A3 multiple of 5. I will take A4 multiple of 7. I will take A5 multiple of 11. A6 multiple of 13. And whatever the condition they have given, you take any intersection A1, A2 that should contain 5. If you take any 2, you can take this intersection, this, you will get 5. You will take this intersection, this, you will get 5. And similarly, in this also, similarly here also, if you take any 2 intersection, you will get 5. There is no common element in this subset. See, this is 0, this is 1. There is no common. If you take A1 intersection A2, you will get 5. You will take A2 intersection A3, you will get 5. If you take A3 intersection A4, you will get 5, and m is not equal to n. Therefore, 1 is not equal to 2. The condition holds here because they have given some condition. An intersection am equal to 5 for all n is not equal to m. Means if you take a1 intersection a2, you will get 5 because there is no common element. Similarly, here also, if you take a1 intersection a2, you will get 5. Similarly, you take a1 a3, any subset you take, you will get the intersection 5. The condition holds good here also. And similarly here also, what I am trying, I am taking some example, because in this example they are telling that, no, this option they are telling that an is finite for some integer n greater than or equal to 1. Means if you collect all the subsets and take the union, at least one finite subset, at least one finite subset is there. It is not necessary, because here I am taking, this is infinite set multiple of 2, this is infinite set multiple of 3. If you take the intersection, you will get 5. This is multiple, there is no common element in this one, I have collected such a set, such a subset. If I take any two intersection, I will get 5. So this type of example I can form by the collection of all the subsets. If I take the union, I can form the integer z. 100% I can form the integer z. So this example fails, the option 2, because they are trying at least one finite subset should be there to form integer z. But I can form the set of integer z by taking infinite sets. This is the sum of the example. Therefore, therefore option B is wrong. Now coming to the option C, an is infinite for some integer n greater than or equal to 1. Now they are telling, if you form taking all the subset union, there is at least one infinite subset. No, not necessary, because you can see this example. This is one of the example which fails the option C, because here all subsets are finite. If I take the union, I can get the integer z. So this example fails the option C. Option D, an is countable, finite or infinite for every integer n greater than or equal to 1. Yes, we know that. We know that the set of integer is a countable, and we also know that any subset, if you take that set, it is a countable. Any subset of a set, it is also countable, because the set of integer is a countable set. If you take the subset of integer, that is also countable, because some standard results are there. So by option D, the option D is correct, because the set of integer is a countable set. If you take the subset of the integer, that is also countable. Therefore, option A, B, C are incorrect and option D is correct. Students, I hope you have understand this question. In my next class, again, I will solve some interesting problem. Thank you, students.